Hello Stings, we are ready for part 2 of function notation, and this will be where we see what the work looks like. So we have already filled this out in the previous video, so now we're going to go in and look at this information here. So they give us two functions, one named f, one named g. For f, the function of x is going to be x squared plus 3. For g, the function of g will be x plus 1. So what we're going to do for each of these is set up what we call a skeleton. So in order to do f of 4, what I'm going to do is wherever I see an x, I'm going to put a set of parentheses. So I have x being squared, and I'm going to add 3. So that's my skeleton. What goes in to the function, x right here is 4. This is our x value. That's going to go in for x. So we have 4 squared plus 3. So then when we evaluate f of 4, we get f of 4 equals 4 squared, which is 16, plus 3 is 19. So we need to show our work by showing our skeleton, which is nothing more than putting parentheses in for the variables so that we know what to put where. So here's our x value for the g function. X is going to be -2. To write our skeleton, we do x plus 1. After we have the skeleton made, then we substitute in our numerical value for the variable, which in this case was -2, and then we can evaluate. G evaluated at -2 is equal to -2 plus 1, which is -1. Here we have a situation where we're going to add together two functions. So what we'll do here is we'll take f of 2, so we are going to do our skeleton, and then our skeleton for g of -1 is going to be x plus 1. Now in this case, a 2 goes in for the f, a -1 goes in for the function g. And then we can type this into the calculator, and we get 4 plus 3, and then when we have -1 plus 1, those cancel each other out. So we have 4 plus 3 is 7, 7 minus 1 is 6, 6 plus 1 again is 7. So f of 2 plus g of -1 will yield 7. Okay. Here's a situation where we're going to subtract 3 from the value of the function f evaluated at 0. So what we have here is our skeleton for f of 3, for f of x, and then the other part here has to be written down. We are going to substitute in a 0 for our x value. 0 squared is 0, 0 plus 3 is 3, 3 minus 3 is 0. So this one actually ended up to be 0. G of 8. We're going to use the function g, evaluated at 8, and then whatever we get, we're going to add 2 to that result. So g is our x plus 1, and then we're going to add 2 to whatever that gives us. So what goes in for x is an 8. So we have 8 plus 1 is 9. 9 plus 2 is 11. So g of 8 plus 2 is equal to 11. We now have f of 3 divided by g of 3. So we put our skeleton in for the f function. We put our skeleton in for the g function. They both happen to be evaluated for when x is 3. So here we have 3 squared, which is 9. 9 plus 3 is 12. So I'll have an intermediate step here of 12 over 4, and 12 divided by 4 is 3. So this is the actual final result that you would need to have. Here we have g being evaluated at a symbol. This is the @ sign. We still write down the skeleton. We still substitute this value in, and our result this time is going to be an expression at plus 1. The last example is going to be f evaluated at y. So we'll take our skeleton of x squared plus 3, and instead of an x, now they want us to use a y. So we end up with the function evaluated at y being y squared plus 3. And this has been part 2 of function notation. You simply write your skeleton, put your x value in for that, or substitute in the value of x for the x, and then do the arithmetic.